Hi, welcome. So we're looking at surds, and I hope you get to understand this topic. Make sure you grab a pen, you grab a calculator and a paper or a book just to help you work through some of the examples we'll go through and take some important notes. And also be sure to watch the video to the very end because I'm going to be sharing the secret to understanding surds. All right, so don't forget to follow through everything we do. Now, what are surds? Now, before we go into that, the first thing you need to understand is that surds are about numbers. All right, that's the very first thing. If there's anything you don't understand at all, we're talking about numbers, and that's very exciting because we all deal with numbers in our everyday life. Listen, you go on the bus, you pay money, that's numbers. You buy something, you pay, you eat sweets, that's numbers. Everything, your age is about numbers. Months in the year, numbers. Everything we're doing is numbers. Square numbers, cube numbers, prime numbers. Everything we do is about numbers. And surds are not any different, okay? They are also about numbers. It's just because maybe we are not used to them in our everyday life. Sometimes we are unsure about them, but they're about numbers. Okay, that's the first thing. The next thing, we also need to understand that all the numbers in our solar system are called real numbers. They are real numbers. They are not weird numbers. They are real numbers. So all the numbers in our world are called real numbers. Okay, make sure you remember this: real numbers. And then, of course, real numbers can be put into two main categories. Okay, one category is rational numbers. Okay, so real numbers can be rational numbers. They could also be irrational numbers. So be sure to be aware of this. Our numbers in the world are called real numbers. It's like almost like the mother of all the numbers we know. Okay, and out of these numbers, we have some types that are called rational and other types that are called irrational. It does not mean that some of the numbers have sense and others don't have sense. That's not what we're talking about. The word rational comes from our first 5 letters here, ratio, suggesting that we can actually write these numbers as fractions. Now think about this. Think of any number you can write as a fraction. Yeah, that is a rational number. So if you hear that rational number in math, it means just a number that can be written as a fraction. For example, the number 5 can be written as a fraction. We can write 5 as 10 over 2, or you can think of 15 over 3. Okay, that's also 5. Therefore, what that means is every whole number is a rational number. All right, that's the first thing. The next thing we also need to realize is that fractions in themselves are rational numbers. So 3/4, for example, is a rational number. It's already a fraction. So as long as we can express that number as a fraction, we call it a rational number. Now, how about recurring decimals like 0.3 recurring? Okay, can we write that as a fraction? Yes, of course. We can write it as 1/3. That is also a rational number. As long as we can write the number as a fraction, it is a rational number. How about terminating decimals? Terminating decimals like 0.234. It stops at 4. We know where it stops. We can write it as a fraction. The 4 is in the thousandth place. So we can write this as 234 over 1000. Once we can write a number as a fraction, that number is called a rational number. Now here's the thing. If we cannot write a number as a fraction, there you go, it's called an irrational number. So any number that cannot be written as a fraction is irrational number. Can you think of any irrational numbers? You can pause the video and see if you guessed right. Okay, have a go. Now we have pi, which we use a lot in our maths, or the circles, and in our world of maths. So we have pi, where it talks about how many times the diameter of any circle can fit around its circumference. So pi, on your calculator, you can check it and you will notice that it's 3.141 and it continues. Now, why is pi an irrational number? Number one, pi cannot be written as a fraction. Why can't it be written as a fraction? We cannot predict its pattern. Okay, it is non-terminating. It doesn't stop, and it is not repetitive. It is not recurring. So first of all, it is not terminating. It is not recurring. We cannot predict the pattern. Therefore, that makes pi an irrational number. That's number one. The next thing also, which is also an irrational number, is e. That's the Euler's number, which is of course the base for natural logs. So on your calculator, you can find e. On your calculator, if you press shift or alpha and the times 10 button on your calculator, you find that it is about 2.71 and something else, and it continues forever. Again, you notice here that we cannot predict the pattern of Euler's number, and also it is not terminating. It continues going. It is non-repetitive, non-terminating. Therefore, it is an irrational number, and it's very important. Now that's the next stage I want you to take note of. Get a calculator. Let's try some things. Try checking for the square root of 2 on your calculator and see what happens. Does that fit that purpose as well? Does that tell us about non-terminating, non-recurring decimals? So you notice that square root of 2 is 1.41421, and again it continues. We don't even know where it stops. It is non-terminating. It is non-recurring. That makes square root of 2 an irrational number. And of course, if we check square root of 6, it's also an irrational number. Square root of 6 on your calculator, and if you press that, you will notice it gives you 2.449489. Again, it keeps on going. We don't know where it's going. These numbers are irrational numbers. An irrational number is basically saying a number that cannot be written as a fraction, a number that is non-repeating, not recurring. It is non-recurring, is non-terminating. It is just going on and on and on and on and on, and we cannot predict the pattern. We call it an irrational number. Where do surds come in? Okay, now here's the thing. Apart from, of course, pi and e, which is Euler's number, all other square roots of numbers that cannot be written as fractions are called surds. The square root of any number that cannot be written as a fraction is called a surd. So now think about it. Is there any number that cannot be written as a fraction? Now, first of all, you must understand that if we can write the number as a fraction, it is not a surd. If we cannot write it as a fraction, then it's a surd. Let's look at a few numbers like that. Okay, so first of all, we're going to look at the number square root of 9. Can I write it as a fraction? Yes, I know the square root of 9. It is just 3 times 3, which gives me 9. So square root of 9 is 3. So square root of 9 is not a surd. Not a surd. It's not. It is only a surd if I need to use the calculator to work it out and I can't get a whole number. That number cannot be written as a fraction. So not a surd. So if I check square root of 10, can I write square root of 10 as a whole number? No, of course. If you check with our calculator, you'll notice that it tells me it's 3.162277, and it keeps on going. It does not stop. It does not terminate. It goes on forever. This is very important to understand in surds. The fact that a number is an odd number and I find the square root of it does not necessarily mean that it's a surd. A lot of students think, oh, there you go, 9 is an odd number, so the square root of 9 must be a surd. No, it cannot. It is not, because 9 is a square number. But square root of 10 is an even number, yet the square root of 10 is a surd. Now, here is the thing you need to understand. Here's the secret now. To understand surds, first of all, check, is that number a square number? If it is not, the square root of a number that is not a square number is a surd. So square root of 7 is a surd. Square root of 3 is a surd. Square root of 16 is 4, not a surd. Okay, so if we can work it out, if it's a square number, if it's the square root of a square number, it is not a surd. I hope this understanding helps you to unearth the journey, your journey into surds. Hope you enjoyed. I'm going to do some more practice questions with sets, and hope you go deeper to look at rationalizing sets and all of those weird questions that come in exams. Enjoy it and look out for more. Thank you for watching.